Okay, another thing you're going to encounter is the average of force applied on an object. So for example, with our pitch, the last example that we had, we found that when the batter hit the ball, it had a momentum, a change in momentum of 13.3 kilograms meters per second. Okay. And so one thing about this force momentum equation is that if I change and divide by change in time, the way that you can kind of talk about it is you have the amount of impulse on top divided by your change in time. And this right here is your average force. Okay, so if we still wanted to work with this right here, we could figure out the number of newtons, the amount of newtons that's being applied on this ball during that hit. And so you can put the impulse on top, which would be about 13.3. And then what you need to know is the change in time that it takes for the bat to hit the ball. Now, we can estimate, we know, because the book says, that the impulse of a bat against a ball is about 0.0001 seconds. So if we divide this out, it's going to be a large number. 13.3 divided by 0.0001. Okay, so we can estimate the average force on that ball was about this. So one thing to note here, in this formula, if time gets really, really small, then the average force is going to get really, really big. And likewise, if the impulse changes really, really slowly, it's going to take less force to do that. And so there's this trade-off. If you're moving the same object with the same impulse, the greater time is, the lower the force, but the smaller the time, the greater the force.